Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. Today we'll be talking about linear equation involving area of a triangle. So basically what I'm going to do in this video, I'm going to give an overview, just a general overview, try to remind us things like the types of triangle and the 4 general ways of finding area of a triangle, just to remind us. Then the next video, I'm going to pick each of the method and talk about it. So like I said, always say is that try as much as possible to review the previous videos. And if there is any particular topic you don't understand, go back, have a watch at it, and also try and solve more questions from the worksheet or from the textbook. And if you still have any questions, please feel free to send me a comment, okay? Or drop me a comment or send me a message and I will get back to you. Okay, and all right, if you've not also subscribed, I don't know what you're waiting for. Click on the subscription button and also the notification bell. So when I upload new videos, you'll be the first person to know. So when we talk about the area of a triangle, the area of a triangle is basically defined as the total region that is enclosed by the 3 sides of any particular triangle. So I'm going to write it down because I know some of us are writing, taking notes. So the area of a triangle is defined as the total region, okay? The total region that is enclosed by the 3 sides of the triangle. Okay? So the area of a triangle is basically defined as the total region that is enclosed by the 3 sides of a triangle. So before I start, I will want to talk about the types of triangle. Okay? So I'm going to talk about the types of triangles. So just to remind us, the types of triangle that we have. Okay? So we can have the types of triangle. We can start based on sides. So based on sides, okay? You can break down triangle based on sides. You can also break down triangle based on angles. And also, you can also break down triangle based on size and angles. Okay? So there are 3 ways we can talk about types of triangle. You can talk about it based on size, based on angles, based on size and angles. Okay, so I'm going to start with the first one, based on sides. Okay? So based on size, the first one we have equilateral triangle. So this is when all the 3 sides are equal. Okay, when all 3 sides are equal or they have the same length. So basically, you have a triangle like this. This side is equal to this side, equal to this side. All right. The next one is what we call the isosceles triangle. Now, the isosceles triangle is a bit different, but here, what happened is only 2 sides. Okay. Here, when only 2 sides are equal. Here, just 2. Why in this case? 3. So that means you have a triangle. This side is equal to this side. Then the next one is what we have called the scalene triangle. Here, no sides of the triangle are equal. So you just have a triangle, but in this case, none of the sides are equal. Okay, so that is based on sides. So remember I said we have based on sides and we have based on angles. Okay, so let's go to the next one. B, based on angles. Okay, so the first one we have what we call the acute triangle. So the first one we have is what we call the acute triangle. So an acute triangle is when all the angles you have of a triangle are acute. So that is, they measure less than 90 degrees. Is that okay? So an acute triangle, all the angles are acute and they measure what? Less than 90 degrees. And this type of triangle is usually referred to as an acute angled triangle. So I'm going to write it down. So acute triangle is when all the angles of a triangle, okay, are acute. So when all the angles are acute, so that means, so that is, they measure less than 90 degrees. It is called an acute triangle. An acute angle triangle. Okay. So when they have less than 90, so you have this. So here is less than 90, here is less than 90, here is less than 90. Is that okay? Number 2, we have what we call the right angled triangle. Okay, so it's when one of the angle is 90 degrees. So when one of the angle is 90 degrees. Okay, so you look like this, you have a triangle like this. So this part here is 90 degrees, and this is what we call a right angled what? Triangle. Number 3, the last one is what we call an obtuse triangle. Obtuse triangle. An obtuse triangle, this is when one of the angles of the triangle is an obtuse angle. Okay, so from the word obtuse triangle, when one of the angles is an obtuse angle, that is one of the angle measures more than 90 degrees. So here, when one of the angles of a triangle is an obtuse angle. That is, measures more than that is measure greater than 90 degrees. Okay, measures greater than 90 degrees. So for instance, we have this. We have this. So you can see this angle here is more than 90 degrees. And there definitely it has to be a what? This is an obtuse what? Triangle. Okay? And that's that for that. Okay, so we've talked about based on angles already, okay? And the previous one, I talked about based on sides. So the next one I'm going to talk about now, which is C, is going to be based on both sides and angle. On both sides and angles. Okay, so the first one we have the equilateral triangle. Okay, so that means in this case, all the sides, okay, the equilateral triangle, all the sides and all angles are equal. Okay, so in equilateral triangle, all the sides and all the angles are equal. Number two is the isosceles triangle. So the isosceles right angle triangle. So in the isosceles right angle triangle, what happens here is a isosceles triangle, but also right angle. So that means it's a triangle in which two sides and two acute angles are equal, and one of the angle is equal to 90 degrees. So it's a triangle in which two sides and two acute angles are equal, with one angle equal to 90 degrees. Okay. Number three, the next one is the obtuse. So this one is an obtuse isosceles, okay, triangle. So in an obtuse isosceles triangle, this is a bit different. Here, the two sides and two angles so two sides and two angles are equal. Okay, two sides, two angles are equal with one of the angle an obtuse angle. The next one, number four, we have an acute isosceles triangle. So an acute isosceles triangle. So the three angles are acute with two sides and two angles measures the same. So three angles are acute with two sides and two angles measures the same. Number 5, we have what we call the right scaling triangle. So the right scaling triangle here, any angle is a right angle, but all the 3 sides will not be the same. Is that okay? So any angle is right angle, but all 3 sides and 3 angles are not equal. Number 6, we have the obtuse scaling triangle. So the obtuse scaling triangle is a triangle with an obtuse angle with sides different or the sides having different measures, okay? So it's a triangle with an obtuse angle with sides of different what? Measures. Number 7, we have acute scaling triangle. Okay, so an obtuse scaling triangle. So this is a triangle, okay, that has 3 unequal sides because it's scaling. And 3 acute angles. Okay, we have obtuse scaling and we have acute scaling triangle. Okay, so that will be that for that. So we talked about the types of triangle based on sides and angles, based on angles, and based on what? And based on sides. Okay, so now let's dive in and see. Then we know the types of triangle. How do we now find the area of each of these triangles? So like I said in the previous video, so if you have any particular line, like say line AB, okay, you will notice that line AB forms a triangle. Or if you have another line, so we have this, the y-axis, the x-axis, you have a line, let's say CD, you will notice that it forms a triangle with the axis. Or if you have 2 lines meeting themselves at different points, this is line AB, this is line CD. You will notice that they end up forming a triangle here, and you could be asked to find the area of the triangle. So in order to find the area of the triangle, one of these conditions must be met, okay? So in order to find the area, you need one of these to be met, okay? So the first one is either all the 3 coordinates, okay? So all the 3 vertices or coordinates are known. Okay? Or if all the 3 are known, or you can say 2 sides, okay, or length, of a right angle. So now you now know the meaning of a right angle triangle. Okay, so the two sides or the length of a right angle triangle. So the two sides you really need here is base, the height and the base. So the base and height are the most crucial, okay? So to be exact, the two sides that you need to find the area of a right angle is the base and height, okay? The next thing, or all the three sides are known, okay? All three sides of the triangle. So all three sides of the triangle are known. So if you don't know all three sides, or you can also have two sides and the angle between them. So in order for you to find the area of a triangle in line equation, it's either you know all three coordinates of the triangle, okay? You know the two sides, so basically you know the base, you know the height if it's a right angle triangle, you know all the three sides of the triangle, or you know two sides and the angle between them, okay? All right, so we're gonna talk about how to do this now. Okay, so we're gonna pick how to do this. So we'll see how do we go about it. So there are four general ways of finding area of a triangle. So we're gonna start with the first one. So we have area. So like I said, the first one that we can have here is when all three vertices are known, okay? So when all three vertices or coordinates all right, are known. Okay, so that means you have a triangle like this. You know the coordinate here. Let's call this x1, y1. You know the coordinate here, x2, y2. And you know the coordinate here to be x3, y3. Okay, so in order to find the area for this is going to be 1/2. Don't worry, I'm going to solve a question on this. x1, y2 minus y3 plus x2, y3 minus y1 plus x3, y1 minus y2. Okay? Then that is that for that. Now also, it's also possible to find the area when two sides, okay? So when two sides or the length are known. So when two sides or the length are known, but it has to be in a right angle triangle. So it has to be in a right angle triangle. So that means we know the two sides, we know the base, and we know the height. And it has to be the right angle triangle, okay? And the formula for that, the area is equal to 1/2 times base times what? Height, okay? Then number 3, another way to find the area is when all three sides are known. So when all three sides are known. So that means for the triangle, we know the three sides. So if you have a particular triangle, you know this side A, B, and C. Now, when all three sides are known, you need to have the Heron formula. So in order to find this, you need to find the Heron formula. Then the area is equal to square root of s minus a, s minus b, and s minus c. Okay, so where s is equal to a plus b plus what? C divided by 2. So the first one, when all three coordinates are known. The second one, when it's a right angle triangle and the two sides, the base and the height are known. The third part is when all three sides are known and you have to use the Heron formula, all right? Then the next one, the fourth one, is when two sides are known. So when two sides and angle between them are known. Okay, so let's assume we have this. This is, let's call this A, B, then this angle between them, C, is known, all right? So we're gonna talk about this when we get to trigonometry. So the formula for area in this case is 1/2 AB sine what? C, okay? So we'll talk about this when we get to trigonometry, all right? So when you go to the trigonometry playlist, you will see when we talked about this formula, all right? So for this video series, I'm gonna just concentrate on the first three. I'll concentrate when all the three coordinates are known. When it's a right angle triangle, you know the height and the base. And when all the three sides are known, then you have to use the Heron formula, all right? So that'll be that for this video. So the next video I'm going to talk about, I'm going to start with when the three vertices are known, all right? I'm going to start with this one, the first one. So like I always say, if you've not subscribed, please do so and click the notification bell. So when I upload new video, you will be the first person to know. So I'm going to see you in the next video where we talk about how do you find the area when all three vertices or the coordinates are known. All right, so I'll see you soon.